Good afternoon, everybody. There's not that many of you yet, but we do need to begin. Hopefully, the ones who do not attend the class will join us later. Just wanted to mention because that in another section somebody asked, is there going to be extra credit today for attendance? Well, I have to tell you that I will never ever tell you ahead of time whether or not there'll be extra credit for attendance. You have to attend. That is a default requirement. It's not optional. Now, will I ever give you extra credit for attendance? Like I said before, perhaps if I see that there is a very low attendance on a particular day, I might actually do that. But I will never tell you ahead of time. In addition, I might do it at the beginning of the class, in the middle of the class, in the end of the class. And one more thing you should keep in mind, when I do that, I pull up the poll and I want you to tell me yes if you want extra credit. So every time I do that, there's 2 or 3 students who actually don't say yes. Guess why? Do you think it's because they don't want extra credit? No, that is actually because they're not paying any attention to what is going on the screen. They are doing something, whatever it is they're doing, and they are present in name only. So then you will also not get that extra credit. The only way you will get extra credit for attendance is if you actually attend all the time and pay attention, and then it just so happens that by pure coincidence, the time when you attended for the gazillionth time, I do run that extra credit. But that's the only way it will work. So keep on attending and you will hit it eventually, but I cannot tell you when, how, and why. Oh, that's great. Well, congratulations. But like I said, I'm sure everybody would love extra credit, but you guys have to earn it, right? You can't just have it because of the happy events or unhappy events. That's not going to be fair to everybody else. I give extra credit. I give opportunity for extra credit to everybody equally. So everybody has an equal chance of getting extra credit regardless of personal circumstances and so on. It's just for hard work and for regular attendance and for trying to learn the material. So while I do congratulate you, but that doesn't qualify for extra credit. Sorry, that's just qualifies for congratulations. But in any case, yeah, that this class is not much better either. And by the way, earlier section I had more people. It just seems like morning classes generally have more students attending. Well, there's nothing I can do about that. I think I told you last time that for the next semester, for this reason, among others, they have dramatically reduced number of these live sessions. I don't know if you noticed already if you're signing up. I teach 5 sections of actually Philosophy 101. I don't know if any of you guys need Philosophy 101, but if you do, you can take it with me. However, only one of them will be live. The other 4 is fully online, and most of the classes will be fully online, and most professors, almost everybody only teaches now one live session. And the reason is it's just stupid to repeat the same thing time over and over again when you have like 2-3 students attending. It's just easier than to put up a video from an earlier session and not waste everybody's time. So for some reason it seems like there's a weird delay on Canvas. I don't know why exactly. I got it in a previous class too. Hopefully you can hear me well. Can you hear me well? Is there any delay in the sound? Yes, you guess means you hear me well. No means you do not hear me well. Well, okay, at least if some of you hear me well, that means that the problem is not with the sound, and if there is a problem, it's probably with your computer. But my picture keeps on freezing. I can see, and especially when I was writing down. Well, I will put up the screen shot video later. It definitely should have the sound fine, but again, the picture may get slightly freeze every now and then. So anyway, let's go on. We only have 2 classes left, right? We only have today and then Tuesday. On Tuesday we'll finish chapter 6, 6.6. That's all we have. Last extra credits will be distributed between today and Tuesday. After that, there is Thanksgiving. Yay. This year it's a little sad, but nonetheless, at least we have a day off. And then there is a last week which has 2 reviews, all review. And then there is the final on December 8th. And that's it. We're done. So definitely make sure that you do not relax now. It's not the time to relax. December 8th will be the time to relax. Right now it is the good time to do your last push and make sure you do your best. Okay, let's look at what we have left. That'll be completely based on what we did before, so let me just remind you again. What did we do? We were talking about simple statements, compound statements. Each simple statement is again true or false. We can have these combinations of compound statements. Negation, like not A, that's an example of negation. That just means you are changing the truth value to the opposite, from true to false and from false to true. Conjunction, D and C, we do describe it with a dot, remember. And what is the rule for conjunction? You should know these rules now. So what is the rule you should remember? It's just one line really, which you really should keep in mind. And that line is what? When they both true, it's true. Yes, so if it's both true, then it is true. Now, disjunction, such as P or E. Yeah, that's weird delay. What's the rule here? Just another simple rule to remember. Whereas this one, both true is true, this one is both false is false. So when they're both false, the result is false. In all other cases, it is true. Well, I usually go by both false and false, but whichever way it helps you to remember, it's good enough. Okay, so this is for disjunction, this is for conjunction. Now then remember there is also implication, so if N, then F. Now what's the rule here? Again, just one line you should remember: when you go from true to false, that is false. In all other cases it is true. And finally, biconditional, when you have B, triple bar, R. Here you have 2 situations when it can be true. One of them, if both of them are true, then the result is true. And the other one, if both of them are false, the result is also true. So you have to actually keep in mind both of these situations. And also when it is both false, that's also true. Okay, so this is the rules you should know. And based on that, if you know all that, today should not be very hard. It's just a methodical application of these rules. So again, this is the operators: negation, conjunction, disjunction, implication, equivalence. And we just say no, not, and, or, if then, if and only if. This is how we describe it in words to make it sound nice. Truth tables. What is a truth table? Truth table is just an arrangement of all possible truth values for whatever proposition you have. Note that if proposition is short, then of course that doesn't take very much time. And last time we looked at, for example, what would be a truth table for just some sort of generic disjunction, say P or Q. Remember, we did have this truth tables. But note that you can have something quite a bit longer than that. And in this case also you can calculate the truth value. One of the most important things to get yourself started in this case is to figure out just how many lines do you need. How many lines do you need, for example, for something like this? And the rule here is very simple. It's based on algebra. So there is a tiny little bit of algebra you should refresh your memory on. It is 2 to the power of n, and n would be your number of propositions. Simple propositions. How many do you have? How many do you have here? 2, exactly. A and B. So then it will be 2 to the power of 2. This is how many lines you need, which is, remember your algebra? So it's basically 2 times 2. Yeah, it is 4. Note that if you had 3, that would then be 2 to the power of 3, which is 8, right? 2 times 2 times 2. If you had 4, then that would be 2 to the power of 4, 2 times 2 times 2 times 2, which is 16, and so on. Okay, let's do now this simple one on the board, the way it is supposed to be done, so that you guys could understand it step by step. That actually is there, but I want to do it on the board, just so that you could see how it's done nicely and methodically. Right, so this is how you do it. First, remember that since you have 2 of them, A and B, you will need a column for both of them, and then you will need to write down your actual proposition. And the proposition, remember, was A or not B, therefore B. Okay. 4 lines. Every time you have, your number of lines, you have to divide it in half and have half of them true and then half of them false. So if you had 8, how many true would you need? If your number of lines is 8, you would need 4 true, yes, and 4 false. Since here we have 4, how many true do you need? 2, exactly. So this is where you start. Your first letter, you go 2 true and then 2 false. This is your first column. Next column, you need to have half of that. So since here we have 2 true and 2 false, next one will be 1 true, 1 false. Once you hit the 1 true, 1 false, you're done, because you can't divide any further than that. So it is true, false, true, false. Note that that is the last column here. If you had 8 of them, then you would have 4 true, 4 false, then 2 true, 2 false, 2 true, 2 false, and then you would have true, false, true, false, true, false, true, false. So it would be bigger table. But to begin with, we just do this nice and short one. In fact, in class we're not going to do a long tables. It doesn't make sense. But the principle is always the same. You divide it by half, you have half true, half false. Next column you divide it by half again, you have 2 true, 2 false. Next time you divide it by half again, you have true, false, true, false, true, false. Okay, that actually is all the combinations of your 2 components. But now you have to calculate what you have here. How do you do that? Well, note that again, first you have negation, not B here. Every time you have a negation, you have to actually do that change, because remember, negation flips your true value to the opposite. So this is your B column. Underneath not B, you have to write down the opposite of that column. Every true you change it to false, every false you change it to true. So this one will be false, true, false, and true. So that's the value of your not B. Now you calculate what you have in your parentheses, right? Because just like in math, after you've done that, now you have to know what's here. How do you do that? You apply the rule. The rule would be for disjunction. What's the rule for disjunction? Well, I'm not going to wait for you to answer, so remember disjunction, both false, false. That's the rule. Now this is one column, this is the A column, this is the not B. So this is the two columns you're comparing, that one and that one. And you're looking for any instances when you have both false, because that will be a false, and in all other cases it will be true. That's not the case, that's not the case, that is the case. So that will be a false, that's not the case. So all these ones are true, this one is false. That's the value inside the parentheses. Okay, note that you have one more operation now. You have to go from that to B and apply the rule for implication. What's the rule for implication? Remember, from true to false, it is false. All other cases will be true. So B is here, but the column is here. So we kind of look in this way, right? We're looking from this to this. You understand why, right? Because we can take this column and bring it here. That way we'll be looking that way. But we don't want to waste time. So we just look backwards. And we look, this one, when this one is true and this one is false, that'll be false. And in all other cases, it will be true. Do we have that? Yes, here and here. So this will be false, this will be false, and the rest of them are true. And this is our final value for the whole thing. Okay? Hopefully that was clear enough. We will do many exercises today, so if it wasn't very clear, then you can tell me. Now we will also repeat kind of that in here, because it has this step-by-step process. So once again, how do you determine number of lines? Take your number of proposition, and then 2 to the power of your proposition will give you the number of lines. So in some cases it can go as high as 64. We will not do anything as long as that, but you can do it for propositions of any length. It's just gonna get longer and longer, and computers do that automatically. It's very easy for them. For human beings it takes more time, but this is the principle. So once again, this is what we did on the board. Let's take a look at it again. First line, for your first proposition, you just do half and half. So true, true, false, false. Next one, half of that. True, false, true, false. Then negation, in which case you just flip your B column, so not B would be false, true, false, true. Then you calculate what's in parentheses by applying the rule for disjunction and comparing your A column to your not B column here. So that we already have it. So this is the first step, second step, third step, negation. This is the, again, result for disjunction. So this is what your disjunction gives you. But then you still have to do this operation because it is outside parentheses. So once again, you are kind of looking that way to your B column, and you're looking for the instances when it is from true to false, such as here, which will then be false, right? And here it will also be false, and the other two will be true. So this is what they got. Once you're done with all that, you put it in this kind of box to make sure you understand this is your final value. What is this value? Why do we look for true and false? What do you mean, why do we look for true and false? Why or where? We look for true and false because that's what we should do. We're calculating all the possible true values. So note, what does it tell you? It tells you when A is true and B is true, the whole thing is true. When A is true and B is false, the whole thing is false. When A is false and B is true, the whole thing is true. And when A is false and B is false, the whole thing is false. So that just gives you all the possible values for all the possible combinations of A and B. This is all there it can be for two of them, right? Either they both true, they both false, or A true, B false, A false, B true. So that just lists all the possible combination, and that gives you all the possible values that whole thing will take in each case. Because remember, this is a true function. True function will always have just one result depending on the value of its components. If both of them are true, then we calculated that the whole thing will be true, and so on. Now, why do we need that? We will see in a few minutes, but this is basically what you do. Okay, so it simply describes to you in every single possible instance what will you get. Let's do an exercise now. You guys do that. This is the proposition. Build a truth table for it. Calculate what do you have. For extra credit, I'm only looking for one thing. Once you do that, let me get you started, right? I will do it on the right side, but simply because there's not enough space, it really doesn't matter. You don't have to do it on any particular side. In fact, you don't even have to do it on any side at all. You can take a shortcut and just do a G underneath G, H underneath H, whatever way you prefer. But let's do it here. So you have G and you have H, right? This is just 2. So again, you will only have 4 lines. Again, you will start with half of them true, true, false, and false. And this one will be true, false, and true, false. And again, that would be all the possible combination of G and H. And note there is nothing else here. It's kind of long, but there's only G and H. Now, in order to calculate, you of course have to go methodically. First you calculate what you have in your parentheses, then you see what you have in your brackets, and finally you do this last one. Note again that an arrow is just the same as a horseshoe, so there's no difference here. You can keep in mind that it is just a horseshoe, right? Not to confuse you too much. Okay, so do the calculation. You'll get one last line, just like here. See, this is the last line. Give me this last line. So it will be something like this. In this case, you would give me TF, TF. So just type it in your chat. And once you type it correctly, the person who gets it correctly gets extra credit. So, but everybody should do the exercise. I know what it is supposed to be, obviously, so I will see whether you got it right or not. Now, fair enough. I will do it after we get the correct answer, just so that you guys could see how to do it, in case if you are confused. That is incorrect, Emil. That's not the correct answer. If nobody gives me the correct answer, I'll just do it myself and you guys will see what you got wrong. But you obviously should try the exercise, because even if you get it wrong, at least you will get some practice. That's the whole point of this live sessions. Otherwise, I could just assign you homework and be done with it. Well, anybody else got a result? Okay, without wasting too much time, let's do it together. So where do you start? You obviously start in your parentheses, right? That's the first operation. It is a horseshoe, so what are you looking for? You're looking for from true to false, and it will be false. In all other cases, it will be true. Okay, so this is your G, this is your H. It's the same. This is the two columns. Which one is from true to false? This one, right? That's the only one which will be false. All the rest of them will then be true. So you got this first one. Are you following me? Okay, what's your next operation? Now you have the parenthesis part. You have to stay in brackets, so now you have to do this operation. That would be your dot conjunction with G. This is your G column. This is your column in the parentheses. What are you looking for in case of conjunction? You're looking for both true, which will give you true. In all other cases, it will be false. So this true, so that will be true. This is not, and this is not. So all the rest of them are false. So now this one is your column inside the brackets. But we are not done yet. We still have one more operation, which is again a horseshoe going from this column to your H. So this is your, I will circle it, column which is the brackets. This is your H column. And what exactly are you looking for? Well, it will be true always, except for the case when you go from true to false. Here from true to true, so it is true. Here from false to false, so it is true. Here from false to true, so it is true. And here from false to false, so it is again true. This is the result you should have gotten. Okay, is anything unclear about that? Yes, as in something is unclear? What is unclear? Well, because that's what you got. I mean, they don't have to be anything, really, until you calculate them. We will talk about what does it mean in a second, but this is what you got. You applied the rules, you got all true. Why are they all true? Well, that's because this combination happens to always produce the true result. So that is the result I was looking for. I don't know why you guys got the different one. That's what I don't know. But of course, obviously, you made a mistake somewhere. If you applied the rules correctly, you should have gotten all true. And once again, the rules are very simple. You start inside the parentheses, you see what operation it is, you remember the rule, you apply the rule. Yes, it only from true to false. Remember, out of the four combination, everything else was true. From true to false is false. From true to true is true. From false to false is true. And from false to true is also true. All other combinations are true. The only one where you get false is from true to false. We did talk about it last time. We had an example from language. Remember the Alison Cooper Wolf Blitzer example. If you forgot that, then go back, take a look at it again. But the point is, this is what you should remember. Okay. Now, once you got that, you can actually classify your statements, because that does tell you something about the statement. The truth tables used to determine whether the truth value depends solely on its form or whether it also depends on the specific truth values. Note that in this case it does not depend on its form. Why? Because no matter what the form is, it actually is always true. When compound statement is always true, as in this case, we call it tautology or tautologous statement. You may have heard that. Oh, it's tautology. What do people mean when they say that? That's exactly what they mean. It is always true. It is something which is so blatantly obviously true that when you say that, the other person is just flabbergasted. Why did you even bother saying that? It is so obvious. When we see the example from language in a few seconds, you will understand what I'm talking about. But just remember, when you calculated you got all true, that's a tautology. Now what if you got all false? That is also possible, right? Then it is a self-contradictory statement. Self-contradictory statement. That's when it is always false, no matter what are the values of the components. This is an example of self-contradictory statement. Note they already calculated this fairly large table and they got all false. What if it's neither all true or all false? Well, then it is called contingent. All other cases are contingent statements. So you can have three possible combinations. All true, which is tautology, tautologous statement. All false, self-contradictory statement. And all other cases where you have at least one true or at least one false are contingent statement. Note that all the tautologous statements are necessarily true, true by necessity. And all the self-contradictory statements are necessarily false. Why do we care? Well, it actually does tell us something about the statement itself. In this case, if the proposition is either logically true or logically false, true value depends merely on its form, has nothing to do with its content, then you can immediately determine the true value just based on the form of a statement. That immediately tells you that the statement will always be true, or the statement will always be false. Also, it tells you that that does not give you any information about the outside world. So let's look at the example from language so you could understand how it works. What would tautology look like? Suppose your mother is by the window and you're getting dressed. You're going to school or something. And you want to know what the weather is like. And you ask her, Mom, what's the weather like? Is it raining? And she tells you, it is either raining or it is not raining. Now that's a tautology. That's a statement which is always true. Note that under any circumstances, it will always be either raining or not raining. Sometimes students say, what if it's snowing? Well, if it's snowing, then it is not raining, is it? So that then is covered by this other part. So what would you tell your mother if that was your answer? You would probably say, well, thank you, Mom. Very informative. Genius. I know it's either raining or not raining. That doesn't tell me very much, does it? That's why. That's what it means. That statement gives you absolutely nothing about the actual state of affairs. It is either raining or it's not raining. It's like, well, duh. And that's exactly what tautology is. Yeah, anyway. Now, how about contradiction? How would contradiction go? Well, contradiction would go like something like this. It is raining and it's not raining. That's a contradiction. Note that it is literally impossible. How can it be raining and not raining? Well, I guess if you're talking about some large area, you can say it's raining here or not raining there. But of course, if you're talking about just in front of your window, it will either be raining or not raining. So that is a contradiction. It's again not very informative. Because if it's raining and not raining, you don't know if it's raining or not raining. So this is what they are. And if you do the truth tables for either one of them, you will see that this one is always false, the previous one is always true. Okay, now, when we compare two statements, build a table for them. There's few other things we can say. If they are exactly the same, if the result we see is exactly the same, they have everything in the same place, we call them logically equivalent. So two statements, note that before we're talking about the one statement. Two statements, when we compare them and we get two values exactly the same, it's logically equivalent statement. Now, For two propositions that are logically equivalent, the biconditional statement formed by them is tautology. So if you take these two statements and join them by the triple bar, and you calculate the truth value now here, you will get it always true, because it will be always a tautology. Now, you may have an opposite situation, then they actually are absolutely opposite on each line. So true here, false here, false here, true here, true here, false here, true here, false here. Note that not a single line has the same value. Now that would be the contradictory statement. So if they all the same, equivalent, all different, contradictory. Now, naturally, again, you may have situations in between. They are not exactly the same. In that case, if they have at least one true value on the same line, and note that in this case we're only talking about true value, not the false value. It doesn't matter that they have false value on the same line. But if they have true value on at least one line, we call them consistent. Could be more than one line. But if it is at least one line, it's consistent. On the other hand, if they don't have that, then they are inconsistent. Note that this one has false on the same line. But that doesn't matter. It is inconsistent. So any pair of propositions is either consistent or inconsistent. Obviously, if it is equivalent, then it is consistent. How about if it is contradictory? Well, it obviously will be inconsistent. But there could be a situation when it is inconsistent but not contradictory if it has false value on the same line, because that's not enough to consider it contradictory, but you can say that it is inconsistent. So that's basically just says the same thing. There is an overlap, obviously. So some of them can be logically equivalent and consistent. Some of them can be contradictory and inconsistent, but some of them can be just consistent or inconsistent without being logically equivalent or contradictory. You understand why, right? I did not confuse you with this. So if you look at the table there, well, next slide, but we'll sum it up. Okay, let's go back a little bit. So why do we care? Well, we basically evaluate statements, right? We're talking about some statements some people could be making, for example, and we want to evaluate whether what they are saying is rational. Book actually does have some examples there, and if you go deeper into chapter 6, there is more exercises and more application for all of that. We're not going to go deeply into that stuff, but the idea is this: you can actually evaluate statements actual human beings making and see whether they are consistent, inconsistent, and so on. There is any rational position. If they at least consistent, then you can work further with them. If they're not even consistent, if it's an inconsistent statement, then it is basically junk. There's no possibility that this position even makes sense. So once again, let's sum it up in case if you are confused. If it is exactly the same on each line, it's logically equivalent. Opposite value on each line, contradictory. At least one line on which they are true, it's consistent. There's no line on which it is true, inconsistent. So just a couple of examples maybe. Let's say if you have two statements, right? One here and two here. This one is like true, true, false, true. This one is false, false, true, false. So what are they? Yeah, contradictory, exactly, because they all exactly opposite. And note that they're also inconsistent, because again it satisfies the requirement for inconsistent too. They do not have any line in which true value is above true. Now, suppose you have this situation. Inconsistent, exactly, because they do have false on the same line, so we can't say they're contradictory, but nonetheless they are inconsistent because they do not have true on the same line. Okay, and similarly, if they had exactly the same true values on all the lines, they'd be equivalent, but in order to be consistent, they don't need that. As long as at least one line has true on the same line. So in this case, for example, let's say this one was true, that would immediately make them consistent, because they already have at least one line where they're true. Everything else is different, doesn't matter, they're consistent. Okay, so there's some overlap between consistent and equivalent, and between contradictory and inconsistent. Nonetheless, it's always easy to figure out if it is. First, evaluate logically equivalent contradictory. If either one of these applies, that is your relation. If neither one of them will apply, then you can further look, are they at least consistent or are they inconsistent? Okay, so let's do exercises now. Do the truth table for these two propositions and then figure out. First, look whether they're logically equivalent or contradictory. If neither of these works, then consistent or inconsistent. And I'm looking for your answer, and it will be one of the four, obviously. If you give me the correct answer, you get extra credit. It could be either logically equivalent, or contradictory, or consistent, or inconsistent, based on whatever you get when you actually do the truth tables for all of them, for both of them. Well, there's just two of them. It's not very difficult, because they actually have the same two propositions, right? F and M. So that actually is not that hard. He's good. He's sleeping right here. Made a few sounds along the way. I don't know if you guys noticed it. He was not very happy with all the talking. Well, it's not always the case. Sometimes he enjoys the little exercise, scratching something, and playing with his toys. But yeah, mostly he does take a nap. Well, any result? Anybody got anything? No result? Why not? Well, we can do it together, but then nobody gets extra credit. So what? Just give me whatever you have. If it's wrong, it's wrong. I'm not gonna take any points off. That's correct. What were you afraid of? They are inconsistent. See? Was it hard? I mean, why would you not want to try that? Good job. Third extra credit, Emil. Yeah. Okay, let's do it together so you guys could see. It is again fairly easy. So just list all the values for yourself. You have F and you have M. Oh, this delay is so annoying. Okay, so two of them are true, two are false, and this one true, false, true, false. Okay. Then here you have conjunction. So it's very easy. You just look these two columns, you already have them. Look for the situation when you have what? Both true will be true. So this one is true, right? All other ones will be false. That's it, you're done with this one. Again, why is it the case because the rule for conjunction, they only true when both are true. So these two are true. The rest of them are never both true. Okay, how about these two? Well, first you do in parentheses, and that would be disjunction, right? So because it's disjunction, the rule now is they only false when they're both false. Not the case, not the case, not the case. This is the case. So you got false here. All the rest of them are true. But that is in parentheses, so you still have to perform this operation because you have to change the true value to opposite. So instead of true, 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 false, you now will get false, 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 true. Right? The exact opposite of that. And that would be your value for this whole thing. So this is one, this is the other. So now you are comparing them. Are they exactly the same? No, so it's not equivalent. Are they completely opposite? No, they have a couple of F's in the same spots, so it's not contradictory either. Are they consistent? In order to consistent, they have to have truth at the same place. They don't. Are they inconsistent then? Yeah, well, that's the only one left anyway. Yes, they are inconsistent. So that's it. That's how it's done. Inconsistent. Okay, let's try another one. Let's see if somebody else can get extra credit. Or maybe Emil will get another one. Same exact task. Evaluate these two. No, you're comparing them. You're looking, are they exactly the same? Are they completely opposite? Do they have truth in at least one position? Or do they not have truth in any positions, the same position? And that consecutively gives you equivalent, contradictory, consistent, and inconsistent. Well, try your best. I mean, what can I say? Once you build a table, you should be able to do the table, right? Once you do the table, then just see if you can figure out. Great. Emil seems to be really getting it. It is consistent. You force extra credit. Good job. Yes, okay, let's do it together again so that you guys could hopefully see how it works. So now we have K and L. So we again do true, true, false, false for K. And we do true, false, true, false for L. Now here we have not K, so it is negated. So you have to use the opposite of this. So let's just put it here. False, false, true, true. Right, it's just exactly the opposite of K. It's not K. Okay, so now you do the horseshoe relation from this going to L. This is your K, not K column, this is your L column. You're looking for what? Since it's a horseshoe, you're looking from true to false, which will give you false. In now other cases, it will be true. So this is not the case, this is not the case, this is not the case, this is the case. From true to false. So this one will be false, and all the other ones will be true. So now we are done with this one. This is our final value here. Let's do this one. So K we already have. This is our K. Now we have to make sure we actually have a negation of L, not L. So we are just flipping all this to the opposite. This is false, this is true, this is false, and this is true. Well, we kind of again looking backwards, right? From K to L. If you really want to look forward the way you're supposed to, you can just rewrite the K column here. Let's do that, right? Let's do that. So we simply take in this column and put in it here, so that it would be easier for you guys to see. Know that you don't have to do that, you can just look at it right there, but we will do that. So this is what we have the two columns, this is our relation. So again the same rule, right? It will only be false when you have from true to false. So that one will be false then, right? From true to false. Not this case, not this case, and not this case. So all these three is true. And that is your final column here. So you're comparing these two columns. First you look, are they exactly the same? So this one is true, false, true, 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 false, true. Are they exactly the same? Sandy, are they exactly the same? No, so it cannot be equivalent. Are they completely opposite? No, because they have truth on the same. Do they have truth in the same position at least once? Yes, so they are consistent. You reach the end of it, because since they are consistent, they cannot be inconsistent. That's it. There's only 4 of them. That's the answer. Okay, fine. So this is consistent. Let's do the last one. Again, for extra credit. Well, hopefully Sandy is getting there. Try this one. Sandy, try it. Try doing it yourself. Again, how do you do it? Well, start like I do. Draw to yourself the values. How many do we have here? How many simple propositions? Know that it's kind of long, but how many simple propositions do we have? Sandy. Four. What are they? What are the 4? 3. Why do we have 3? What is the 3? Tell me. Note that not A is not a simple proposition. That's a compound. How many simple propositions are there? Can you name them? Are you guessing? Okay, one is A, the other one is X. There's nothing else. What else do you see there? But there are at least 2 of them, right? There's an A, there's an X. That's the 2 simple propositions. Again, note that not A is not a simple proposition. Remember, at the beginning of class we were talking about that. The very first slide. Not A, that's already a compound proposition. So that is not simple. Simple would be A and simple would be X. So again you have just 2. Yes, the simple propositions is just a letter. Or simple statements. I think the book calls them simple statements. It's kind of a little bit confusing when they actually call it statements, but it's supposed to be proposition. Anyway, it's the same thing, right? Simple proposition, simple statement, that would just be the letter. Okay, so since there's 2 of them, how many lines do you need? 2 to the power of 2, which is 4. Yes. And again, that's just like the previous examples. You do 2 true, and then you do 2 false, and then you do true false and true false. That delay is so annoying. Okay, and now just calculate here and get the column for this, column for that, and compare them the same way we were doing previously. You're applying the rules. That's indeed the way we did it for the last class. The rules are all the same. If it's negation, you have to negate it. Turn the true value to opposite. Conjunction, if they are both true, they are true. All other cases, they are false. Disjunction, if they are both false, they are false. All other cases, it's true. If it's material implication from, say, A to X, then that would be from true to false would be false. All other cases will be true. And for equivalency triple bar, you have two situations when it's true, either if they're both true or if they're both false. In both cases, they are true. If one of them is true, the other one is false, it is false. That's the rules. You just apply them. So whoever gets the correct answer, gives me the correct answer, gets the plus the extra credit of today. Yes, you look for two values, naturally. You look for situations when they both are either true or either false, in which case it will be true. In all other cases, it will be false. That's the only one where you actually look for two possible things, not one. But it's not that much harder than looking for one. Now, anybody reached any kind of result? You compare them. Remember? And if they are exactly the same, then they are equivalent. If they are completely opposite, then they are contradictory, and so on. And then you give me the answer. You don't give me the answer actually, because you already have maximum extra credit. But you can keep it for yourself and wait for the result. It still is good practice to do it. That is incorrect, Karen. Made a mistake somewhere. Contingent, that's from a different story, I know. They can continue. One preposition can be either tautology or self-contradictory or contingent. Two prepositions, when we compare them, cannot be contingent. Okay, let's do them together then, while we still have time. Okay, so note that you have to obviously negate A. Make sure that you do that. You have F, true here. Because obviously this is your A, so not A would be the opposite of that. Then you just look for your relation, which is, yes, in this case equivalency. So if it's both true or both false, it will be true. Do you have any of that? This is your not A, this is your X. This is what you're comparing. You're comparing this and this, right? So this is not the case. This is the case, so this one will be true. This is the case, so it will be true. And this is not the case, so this two will be false, but this other two will be true. So this is your, what should be your result for this one. Okay, now let's do this one. This one is a little bit longer, right? You have not A here. You can rewrite it, but I'm not gonna do it. So this is your not A. The X column is again here, and your relation here is conjunction. So if it's both true, it will be true, otherwise it will be false. So again, we're looking at this one and this one. This is not the case. This is not the case. This is the case. This is not the case. So all other ones are false. Right? Can you see why? Because this is true and this is true. So this is true. All other ones are false. Now, how about this one? Well, we need actually to make sure that we have not X, because we still don't have a column for not X. So we do the opposite of X column, which will be false, true, and then false, true. helps if you have them on the same level, but it's kind of difficult for me to keep it on the same level. Okay, so this is your node X, this is your A, and again you have the conjunction, so only if both of them are true you will get true. So these two are true, so that one will be true, and that's it. The rest of them are all false. Okay, but this is your right side, this is your left side. You still have to do the disjunction between them, right? That's your last relation, because you already calculated this parenthesis and this parenthesis, but there is disjunction between them. So we use the conjunction pattern. What do you mean we don't use? The conjunction pattern is they only true when they're both true. And we are looking at this column and this column, and note that they only true in this one position, which is why it is only true here. This is not both true, this is not both true, and this is not both true, even though they are not on the same level, but you can see that, right? So that's why only this one is true and the rest is false. That's the pattern. Okay, so like I said, we still have to do this disjunction. And disjunction, it is only false when both of them are false. So these both are false. This is false and this is false. This is not, but this is. So this is false too. And these two are true. So now that you've done that, this is your right side. You can see that they are exactly equivalent, can't you? This is false, this is false, this is true, this is true, this is true, this is true, this is false, this is false. So that's why it is equivalent. Okay? Okay, so that's all we have for today then. Sorry guys who have maximum, unfortunately there is no more than that. Make sure you come on Tuesday. That will be the last lecture, the last bit of material, and then we will be done with all, including all the extra credits, and then you'll have your Thanksgiving and blah blah blah. Make sure you do homework, 6.2, 6.3. If you still didn't do 6.2, make sure you do it. The 6.3 is also homework for this week. Otherwise, we are done. See you guys on Tuesday. I will. Right now, he's just sleeping very peacefully. Okay, have a good weekend.